In this video, we'll talk about volume on a theoretical level, and we'll talk about, in particular, volume of prisms and how to calculate it. So we've talked before about area, and now we're going to be talking about volume. So area is a two-dimensional measurement of how much space a two-dimensional figure takes up. Volume is all about three-dimensional space, and it's all about capacity. So how much something can hold. And the whole idea is, if we look at a three-dimensional object, let's say, for example, a sphere, which is going to be a little difficult to draw on this thing, but the way we would draw this is you draw what you can see with solid lines and what you can't see with dotted lines. So if you picture a sphere, which would be like a ball, we're trying to think, okay, how much air can that sphere hold? How much space does it take up in a three-dimensional sense? That's basically what volume is. So there are a lot of ways you can measure volume. There are the typical units where we think about, say, for example, cubic inches. Okay, this would be, I have how many of the little cubes that are 1 inch by 1 inch by 1 inch. So 1 inch in width, 1 inch in depth, and 1 inch in height. How many of those can I fit in this sphere? And it might be fractional, it might not be a nice round number, but we could theoretically say, okay, how many of these little cubes can I put in here? And that's the typical mathematical unit, is to use some kind of unit cubed. It could be inches cubed, could be meters cubed, could be cubic feet. But it's that whole idea, how many of these little cubes can I put in this object? And another method, we use units like gallons or liters. Those are also measurements of volume. They're different than our theoretical little cubes, and there may be some relation, but in the empirical system, the system that uses gallons and quarts, there's not as much of a link. It's just someone decided this was a good measurement for a capacity. And there is a tie-in between liters and milliliters and centimeters. There are ways of doing that, but we're not too worried about that right now. So that's volume on a theoretical level. How much space does it take up in a 3D sense? So we're expanding a whole new dimension here. So let's talk about prisms. In particular, we're talking about right prisms. So if you think about a prism, let's take a rectangular prism as an example. So the idea is, basically, I'm looking at a box with rectangular faces, all right angles. That would be an example. That's the typical thought behind a prism. Now, it expands to more than that. You could have a triangular prism. So, like, for instance, it could look like this. Let's say laying on its side. That would also be a prism, and meaning that the angles, if you're looking at right here, you have rectangular sides. That's what a prism is, in particular a right prism. Now you could also have something like a pentagonal prism or a hexagonal prism. Say something looks like this, and then all these sides extend down, and you still have a hexagon on the bottom here, in this case. Okay, so again, in mathematics, they use this term base, and I don't have another word for it, but the whole idea here is that if you think about the base of a prism, in a rectangle it's a little tough to discern which one it is. It doesn't really matter which one you pick. One of these faces could be the base. However, if we go beyond the rectangular prism, if we think about this triangular prism, we would consider this to be the base, the actual triangular piece, because the rest of these sides, faces, are rectangles. Similarly, with the hexagon, we would consider the hexagon piece the base. Either one would be fine. And the whole idea behind a prism is that you're going to take the area of this base times the height. And again, height, that would depend on your base. In the case of the triangle, we're looking at this would technically be our height. If we stood it up, that would be how tall it would be. And likewise, on the hexagon, we're looking at this as our height. So if I take the area of this base, whatever the bottom polygon is, and I multiply that by the height, that will tell me the volume. So this base is a 2D measurement, as we're talking about with area. So we have to find the area of this triangle or this hexagon, and we can use whatever methods we have available to us in order to do that. So let's look at an example. In particular here, I have a triangular prism. Okay, the base is a triangle, and I'll redraw it here, that looks like it has a height of 4 inches and a base of 3 inches. So first things first, I need to figure out the area of this triangle. So the area of the base, which is this triangle in this case, if you remember your formula, you're going to take 1/2 times the base, which in this case is 3, and that's why I'm not a fan of base again. Base of the triangle times the height of the triangle, which is 4. And if we take 3 times 4, we get 12, and then half of 12 is 6. So the area of the base triangle, the triangle at the base of the prism, is 6 inches squared. So then I have to take this number, the area of my base, times the height, which in this case is 10 inches. So the volume of this prism is going to be 6, because that's the area of my base, times 10, which is 60. So ultimately my volume is 60 cubic inches, or inches cubed in this case. So that's one example, and I'm not a fan of the term base, because we're talking about the base of a prism, we're talking about the base of a triangle, and those are two totally different things. But if you find the area of that bottom face, and it might not even be the bottom, but the one face that's not a rectangle, in the case if it's not a rectangular prism. If you're dealing with a rectangular prism, it doesn't so much matter. But in the case of a triangular or a pentagonal or a hexagonal, you have to find the area of that off face, and then multiply it by the height of your prism, or if it's on its side, however long the prism is, basically how far it extends. And then just remember, if you're talking volume, you have to have units cubed in some sort. That's usually how we'll do it in mathematics. I know we talked a little bit at the beginning of the lesson about gallons and liters, and those may come into play later, but we're not so much worried about them right now.